bucka. Haha. You know the deal.
What I'm going to talk about in relations is graphing linear equations. If you recall in the previous lesson, we talked about an example of a linear relation where if we're given the length of a square, we calculate the perimeter, and we came up with this equation where y is the perimeter and x is the length of the square. So also, if you recall, the domain is the limitation on what x can be. In this case, x has to be greater than or equal to 0. We can't have a length that is negative. In other words, we have to have a length that is 0 or greater. So when we're wanting to graph our ordered pairs, we have to come up with some sets of values. And it's going to become clear why these are called linear equations in a second. So we can choose any values for this for x for this relationship as long as they're greater than 0. So we might start with 0 for x, 1, 2, 3, and 4. And it really doesn't matter. Again, I could choose 0, 10, 15, 8. I could choose whatever values I want for x. And what we're going to do now is we're going to substitute in those values into this equation and solve for y. So if we substitute in x equals 0 into that equation, we get 4 times 0, so y would equal 0. So in other words, if we have a length of 0, our perimeter is 0, which makes sense. If we substitute in our value x equals 1, we get 4 times 1, so our perimeter is 4. So if we have a length of 1, our perimeter is 4. And we can continue adding the values of y to the chart here. Really, we're just taking the value of x and multiplying it by 4 to get the perimeter of the square. So if I look at these now as ordered pairs, I've got 5 ordered pairs here. So the first one is 0, 0. The next one is 1, 4. Then we have 2, 8. 3, 12, and 4, 16. So I'm just rewriting these values just as ordered pairs. And again, in ordered pairs, the x value comes first, the y value comes second, in brackets with a comma in between them. So now what I'm going to do is I'm actually going to plot these points on the graph. So 0, 0 is at what's called our origin. That's this point here where x is 0 and y is 0. So if I want to go to 1, 4, that's where x is 1 and y is 4. That's here. 2, 8 would be here. 3, 12 would be here. And finally 4, 16 would be here. And what you start to see emerge here is a line. This makes the shape of a line. And that's why it's called a linear equation, because when you graph this relationship, it makes a line. Now we can actually join these points together with a line. And the reason we can do that here is because we could have values that are decimals. So for example, you could have a length that's say 1.5, which would be about here. Well, if our length is 1.5, we look for our corresponding value for y, and it looks like that's at about 6. So if x equals 1.5, y equals 6. In other words, if our length is 1.5, our perimeter is 6, which does make sense. And again, the reason we can include these values is because in this case, the domain does include all values as long as x is greater than 0. So here's another example of a linear equation, and this might involve getting paid $10 per hour. I think in the previous video I talked about an example where we got paid $12 per hour, but for this equation, just to kind of simplify things, I made it 10 instead of 12. So in this case, we're getting paid by the hour, and presumably we can only get paid for whole hours, so we can't get paid for part hours here. So the domain of x is x has to be what's called a natural number. It has to be 0, 1, 2, 3, and so on. In other words, it can't be a decimal because we're not getting paid for parts of hours. We're only getting paid for whole hours. So we might write that as the domain is all natural numbers. So the way we might write that is like this. When we state the domain, again, the domain is the limitations on what x can be. In this case, because we can only get paid for whole hours, we can only get paid for 0 hours, 1 hour, 2 hour, 3 hours, etc. So the way we would say this is x is the set of all natural numbers. So since x can only be natural numbers, 0, 1, 2, 3, and so on, when we're coming up with our table of values, those are the only values we can use. We can't use decimal values. Normally we wouldn't use decimal values anyway, but that's going to come into play when we go to graph our relationship here. So again, I can choose any values for x, in this case, as long as they're not decimals. So I'll just choose 0, 1, 2, and 3. So if we substitute our values for x into this equation and solve for y, well, if x equals 0, y equals 0. If we work 0 hours, we get $0. If x equals 1, y equals 10. If x equals 2, y equals 20. And if x equals 3, y equals 30. So here we really do have our ordered pairs that I can graph. Now, when I'm graphing this, I'm going to put these coordinates here. So 0, 0 is at the origin here. 110 is here. 220 is here. And 330 is here, and so on. So I can continue to put these dots here. Now, in this case, I can't actually join these dots together with a line. And the reason I can't do that is because if I did join it together with a line, that would say that we could work 1.5 hours. If there was a line here, then there would be a value for x that's a decimal, and a value for y that's between 10 and 20. But in this situation, we're only getting paid for whole hours, so we can only make 0, 10, 20, $30, and so on. So this point here cannot be a point on this relationship. So in this case, we just leave this relation as dots. We do not join them together with a line. So for our last example here, now I've just got a linear equation, and I don't really know what this linear equation is all about. I don't know what it relates to, but it's just a linear equation where we have y equals 2x minus 5. And this is our domain here. So these are our limitations on x. And what that means is x is part of the set of all real numbers, which basically means x can be any value. Negative, positive, 0, decimals, it doesn't really matter. So if we want to graph this relationship, we can choose any values for x that we want. When x can be any values, including negatives, I usually suggest that you choose these, just to give you an idea of what the relationship is going to be like. Choose some negative values, 0, and some positive values. So if we take our first value for x there, I'm going to actually solve this. So we're going to take our first value for x there, which is negative 2. So I'm rewriting the equation, and the equation is exactly the same, except instead of writing x, I'm writing negative 2. So now we go ahead and solve for y, which means we follow order of operations. So 2 times negative 2 is negative 4, and negative 4 minus 5 is negative 9. So if x equals negative 2, y equals negative 9. I can go ahead and do the same thing for negative 1. So if I substitute in my value for x here, x is negative 1. So instead of writing x, I'm going to write negative 1. And then we just go ahead and solve. And you'll notice this is why it's easier to choose values for x. I could choose values for y and figure out what x is, but because y is isolated, it's actually easier to choose values for x and then solve for y, because y is by itself. So we get negative 2 minus 5, and y equals negative 7. If I substitute my value for x here, x is 0. Well, 2 times 0 is 0. 0 minus 5 is negative 5. Keep going, x is 1, 2 times 1 is 2, 2 minus 5 is negative 3. And then my final value here, x is 2, 2 times 2 is 4, 4 minus 5 is negative 1. So looking at the first value there, x is negative 2, y is negative 9. That's our first ordered pair that I'm going to plot here. So this is where x is negative 2, this is where y is negative 9. So the spot where these two points meet, or these two lines meet, is here. That's negative 2, negative 9. If I keep going, negative 1, negative 7 is here. 0, negative 5 is here. 1, negative 3 is there. And 2, negative 1 is here. And once again, you can see it does create a line. We do have a line here. And we can join that line, or those dots together with a line. And we can do that here because x can be any values, including the decimals. And this line actually goes on forever. So usually when it goes on forever in both directions, we want to put arrows there to indicate that it just keeps going and going. So again here we can pick values for x and figure out what the value of y is. And that's an introduction to graphing linear equations. So the last thing I'm going to ask you to do here to practice graphing linear equations is to graph these three relations here. So the first thing you're going to want to do is create a table of values. So for question number 1, you'll notice there is a domain, there is a limitation on what x can be. These are the only values that x can be for question number 1. For question number 2 and question number 3, the domain is all real numbers. In other words, x can be any value, negative or positive. So the first thing you're going to want to do is create a table of values for each relationship and then graph each relationship. And if you want to, you can graph them all on the same graph.